See, last meeting we had a discussion about the Gaganyaan and all that. So today we are going to discuss something on our Earth, our very own Earth, the Mother Earth. And the topic is so relevant today. We are talking about flood, landslide, and warming up, climate change. And it is, as you know, it is creating a lot of havoc in the society life. So many lives are lost, all these problems. So today's talk is very relevant on that one. So let us discuss that. We will start the program as usual with a 1-minute silent prayer. Please join. Okay, thank you. Let us go ahead. So may I invite Chevalier Dr. Koshiyam George, the President of Trivandrum YMCA, to welcome the gathering and also to introduce the speaker today.
Thank you, Mr. James. Respected Dr. K. Ninan, sir, the moderator of the session, Shri M.G. James, YMCA Academy Program Committee Chairman, Dr. Bijoy M.S. Raj, my dear friends and dear children, a very good evening to all of you. As the President of the Trivandrum YMCA, it is my pleasure to welcome all of you to this great meeting, let me tell. Today is the 9th science lecture in the science lecture series started by YMCA a few months back. We have seen very good response and we are continuing with it. Today, our most respected Dr. K. Ninan sir is talking about something very, very relevant. Nothing but global warming and climate change. Today, incidentally, I was watching the meeting between Pope Francis and our respected Prime Minister. So in that I was seeing in the exchange of the items and the books, a book on climate change. It was very clearly seen. Climate change, that is the book. I do not know the details, probably Ninan sir may know it. So that book was exchanged between the two. So today I was just thinking how relevant it is today. Okay, now let me come back to the duty assigned to me as President of YMCA to welcome all of you. I am extremely happy to welcome and introduce Dr. K. Ninan sir, who doesn't need any introduction at all. As you all know, he is the former outstanding scientist and deputy director of VSSC, and also former Emeritus Professor of Indian Institute of Space Science Technology, Trivandrum. He is a university rank holder. You may be very happy to know that he has the rare distinction of getting the first rank for BSc Chemistry as well as MSc Chemistry in the Kerala University. So after his postgrad, he joined Vikram Sarabhai Space Center, ISRO, in 1968, and he served there for 4 decades, 40 years. And he established a state-of-the-art analytical and spectroscopy division, and he became its founder head. And from 1990 onwards, he led a team that developed the rockets, propellants, polymers, and special chemicals for the Indian space program. After retirement from VSSC, he joined as the professor in Indian Institute of Space Science Technology, IIST, you all know. In fact, he nurtured the institute in its formative years, and he guided the students to make India's first student sounding rocket. That's a very big achievement. He has received a number of awards, and the notable among them is the ISRO Performance Excellence Award, which he received from the President of India in the year 2009. He was selected as a full member of International Academy of Astronautics Paris in the year 2012. He has 500 research papers and 28 patents to his credit, and he has guided almost around 30 PhD scholars he has guided. And also, very recently, he was ranked among the world's top 2% scientists by the Stanford University, USA. You all know that. So the profile continues, but I have to stop somewhere, so I am stopping here. We are extremely happy that Dr. K. Ninan sir is giving the lecture today, and that was the 9th science lecture of the YMCA series. It is not the first time he is coming. He has come a number of times in the same science lecture series, started with him actually. So we are extremely happy to welcome you once again, Dr. Ninan sir. Welcome, welcome. Okay. Now I welcome our moderator, Shri M.G. James, who had been with us for all these sessions. In the 9th session also, he is moderating. I am very happy. He is part and parcel of YMCA. I welcome Shri M.G. James. I welcome the chairman of the YMCA Academic Program Committee, Dr. Bijoy M.S. Raj, who is leading the complete academic activities in YMCA. I welcome all I'm seeing many of the ISRO friends. Extremely happy that ISRO friends have joined to hear our Dr. Ninan sir lecture. I do not want to name anyone. There are so many YMCA full members, associate members, YMCA friends, and so many dear children. They are joining actually. I am seeing many of the children, and many of the others are also joining. So I welcome each one of you, and I hope that today evening will be a very good science evening. So I wish you a very nice science evening. Thank you, and welcome once again. Thank
you. Thank you, President YMCA Chevalier, Dr. Koshi M. George. So as it is introduced, we are going to discuss a very relevant subject, and I don't want to take any time from the speaker. So we, all of us together, wholeheartedly welcome Dr. K. Ninan for the presentation and the lecture. Welcome, sir.
Okay. Shall I start then?
Yeah.
I'm audible, I hope so. Chevalier Dr. Koshi M. George, Honorable President of YMCA. Dr. Bijoy M.S. Raj, Academic Program Convener. Mr. M.G. James, Coordinator for the program. Mr. Shaji James, General Secretary. Members of YMCA, my old ISRO colleagues, dear students, and all others who are attending today's meeting. A very good evening to all of you. At the outset, I would like to thank Dr. Koshi M. George for his nice words of introduction and also for his kind invitation. I should compliment Dr. Koshi for having started a very meaningful program for our students on exposing them to various frontier areas in science and technology. I'm very happy to come here again. As Dr. Koshi said, in the beginning, I gave one lecture. I also compliment Dr. Koshi and the YMCA Governing Council for having chosen today's topic, which is relevant not only to Kerala, but India as well as the whole world. In fact, every day in newspaper or in TV discussions, you would have heard somebody or other discussing on global warming and climate change. So you may wonder what further I have to say, because every day you are hearing, reading, etc. So what I'm trying to do is that last 5-6 years, I have collected various literature information on this, and then try to do a scientific analysis of various viewpoints and try to put across to you. Shall I start sharing? Okay, share. Is it visible?
Yes, sir. It is okay.
Okay. So I'm trying to tell about global warming and climate change. What are the threats? What are the challenges involved in overcoming the problem? And also, what are the opportunities available to my young friends in time to come in that endeavor to overcome this great problem? Well, global warming is one of the greatest challenges faced by human race in the entire history of human race, at least last 2000 years if you take. This is not my statement. This is a statement of one of the greatest scientists ever lived on earth, Stephen Hawking, who said that man may have to leave earth and find out homes elsewhere. And he classified reasons for them, 3 great reasons for them. One is global warming, second is nuclear war, and a genetically engineered virus. Of course, let us hope that the COVID is not a genetically engineered one. So if you look at the death which has happened out of these 3 disasters, first one he has seen in his own lifetime, but second and third he has not seen, but he has forecast. He had the good wisdom to forecast that, about 1 lakh people died on the day of bombing, followed by another 1 lakh later on. Today, as of yesterday, nearly 5 million people have died on Earth. But then, because of global warming, direct consequence of that, remember, 600 million people, which is roughly half the population of India, will be dying. Therefore, obviously, this is a great disaster to the whole humanity. But unfortunately, God's own country, we were not at all worried about that because we were sitting relaxed, because we thought that we have got greenery everywhere. We have got sea, we have got rivers. But the situation has changed recently because in several parts of Kerala, during the last 3 to 4 years, the temperature went as high as 42 degrees centigrade. We are even today discussing about 2018 flood and 2019 landslide. We thought that it was over, but then the same thing repeated in the current year also. The interest has further increased when the Nobel Prize was awarded for physics the current year for these 2 gentlemen. Got the Nobel Prize for physical modeling of Earth's climate, quantifying variability and reliably predicting global warming. In fact, their work helped scientists world over to predict global warming and then how that prediction and observed value are very close, and what is the element of natural factors, what is the element of the human factors involved. This could be delineated properly. I will come to those details a little later. So today's lecture, I propose to answer 3 basic questions in any scientific discussion. 3 watts. What is global warming? Is it a myth or a reality? In fact, some people like the former president of USA says that it's only a myth. Many people might have believed at that time so. Then second, what is the impact of global warming on climate and ecosystems of the earth, the present as well as the projected for another 50 years? And what are the remedies? To know the remedy, we should know what are the reasons for global warming, and then what are the methods to prevent the global warming. So that prevention or reduction, what is called mitigation, gives a great challenge to humanity as a whole, because the remedies we have to find out at affordable cost without hindering human progress. So there are very many opportunities to work on these remedies for our students and youngsters in the years to come. So global warming and climate change, as you can understand, is a very, very complex multidisciplinary subject. I don't claim that I know much about it, because I am not a climatologist nor a environmentalist. But what I have done is that, because of the interest last 5 to 6 years, I have tried to collate various information, try to analyze it, then supplement it with my own analysis to see, because one of my PhD program was connected to this work. So let us first look at global warming. Is it a reality or a myth? The advocates say that the past 10 years is the warmest decade on record, which is correct. 2020 is the warmest year on record, and that it is the 40th consecutive above average temperature. Suppose you take a median, then it was 4th consecutive year it was going on increasing. But the critics say that the warmest summers have equally cold winters. Then how do you say it is global warming? So the rational approach would be to take an average of temperature of the entire surface of the earth during the whole year. It's a complicated process of weighted averaging of the earth. And then if you plot, you get a graph like this from 1880 to today or last year. This is plotted relative to the 1950 to 1980, where the fluctuations were minimal. And you see that it is, after initial dip, it is increasing continuously. And then now there is no doubt, looking at this graph, I don't think anybody should have a doubt to say global warming is a reality, because there is an increase of 1 degree from mean temperature from this average to today. Today, earlier it was 14 degree, today it is 20 degree. Not only that, the frightening part of it is that the rate of increase is going on increasing after 2010, and if it continues, we don't know where it will end up. Then rightfully you can ask a question, why, after all, why bother about 1 degree temperature change? 1 degree is a minuscule temperature change. But then it has got, so how the important it is that natural disasters have been classified with how they are progressing with the number of years. So this is how they have been classified in terms of the geophysical events, that is the earthquake, volcanic eruption, meteorological events, namely storm, then climatological, this is the color, this is geophysical events. Some of the slides have not come. Anyway, this is meteorological event. Then this is the climatological. Climatological event means heat wave, drought, and fire. And this is the what you call hydrological event. That means rain and flood. You can obviously ask me, okay, temperature increase, we can understand heat wave. But then how do you say that temperature increase has resulted in heavy rain and flood? So let us look at this graph, which tells you the reason for that. Higher the temperature, higher is the amount of water in the atmosphere, because this graph shows this temperature of at the sea level or the earth level. So if you look at this graph, you see that At 14, with reference to the 14 degree centigrade, which was the global mean a few years ago, about 50 years ago. If you increase by just 1 degree, the relative increase in the vapor pressure is 6.7%. It's a huge increase. So if you increase by 4 degree, the relative increase in vapor pressure is roughly 29.2%. So because of that, when water vapor condenses, the rainfall will be very heavy. In fact, there is heavy rain and flood after the year 2000, and heavy losses despite better warning system and rescue measures. Suppose it was not there, the destruction would have been 100-fold more. For example, Kerala flood. Pictures are not coming, some of them are not coming, it doesn't matter. Kerala flood in 2018, the rainfall on one day was 320 millimeters and the death was 483. Mumbai, there was a flood and the rainfall was 944 millimeters and the death toll was 1094. So that is the indirect effect. Now let us see what are the direct effects. Direct effects are of course heat wave, droughts and forest fire. The heat wave death toll in India, which is said to be under quoted, is about 22,000 during the last couple of years. And the drought, that means 55 million people are affected globally by drought every year as per the World Health Organization projection. Because of that, there is low food productivity as well as there is tremendous water scarcity. There is a forest fire. There was some pictures on the right side because of certain problem in the Zoom. It is not coming through. You know, you would have seen the Australian fire of last year killed 1 billion animals. But the worst among the whole lot was 2010 Russian wildfire, where 56,000 people died in that fire. And the fire lasted for almost 6 months to quench it. Another consequence of higher temperature is the rising sea level. There are two reasons for that. When temperature increases, water density decreases. Lower density of the warmer water. And also the ice melt. For example, for 500 gigaton, that means 500 billion tons of Arctic ice has melted till last year. There is a reduction in 1 million square kilometers of sea in Arctic region covered by the ice. Satellite picture very clearly shows there is a 20% reduction in the Himalayan glacier. And of course, this picture you would have seen in many of your calendars, extension of polar bear. So if this is the situation, what will be the situation after about 2100 AD? The most moderate projection says that there will be 4 degree rise in temperature if we go like this for till 2100. The sea level will increase by about 1 meter, and therefore many places will disappear from the world and millions will get displaced and perished. For example, port cities like Mumbai, Calcutta, Kochi will not be there in the world map. This is Mumbai city. What is shown in red is that the entire thing is underwater. This was the gateway of India as you see today. But at that time, this is how the gateway of India will look like. Islands like Mali, Andaman, Lakshadweep will not be there on the map. And then parts of Kerala also will disappear. There was a picture here which shows that from Chengannur to Vaikam, that whole belt will be underwater. And then London, there was another picture which shows that the famous London bridge as well as our Big Ben, 1/3 of it was underwater. It would not was, it would be underwater. So adaptation of man and animals to such changes in climate is doubtful. 10% of the species, why? Because 10% of the species existing prior to the 18th century have already disappeared. Then The first step in fighting the impending disaster is to find out what is the root cause for global warming. So we'll see what is the root cause for global warming. Global warming, shall I switch off and then I don't know whether refresh and then get. There was a picture here of the globe. Oh no, it's not coming. Okay. See, there was a picture of the globe here. You have to imagine that the sun is here. The sun ray will fall on the earth. The earth will get warm and the earth will give out infrared radiation in this wavelength region. Majority of it will go through the atmosphere, but a certain portion of it is retained by the atmospheric gases, mainly the carbon dioxide, and that will radiate back the earth to the earth. The long wave energy infrared radiation radiated by the earth is retained by the greenhouse gases, and that results in the global warming. So global warming is caused, suppose there was no such global warming phenomena was not there, a scientist by name Fourier in 1820 have calculated that the earth would have been very cold, like minus 18 degrees centigrade. The earth is kept warm by these gases plus the water vapor, but water vapor does not lead to continuous warming because it condenses and then falls back to the earth as water, as rain. But these are the gases whose concentration will continuously increase. You see, 76% of the global warming is due to carbon dioxide, 16% due to methane, and about 6% due to nitrous oxide, and 2% is due to fluorocarbon. But the methane, what happens is after about 25 years or about 50 years of its life in the atmosphere, it will get oxidized to carbon dioxide again at this burden. Whereas nitrous oxide, which has got very long life in the atmosphere, but it is relatively small percent, fortunately. Otherwise, if you touch nitrous oxide, our agricultural process will be definitely affected. So carbon dioxide is the main greenhouse gas contributing to 76% of global warming, and its share is continuously on increase. This graph shows you from 1980 to 2020 how these gases were increasing. Relative to a position of 1990, if you take as 1, the warming potential has gone up by 40%, and the more increase is in carbon dioxide. Therefore, we have to now concentrate on carbon dioxide. But then if you look at the carbon cycle of Earth, which is a huge thing, see about 770 plus 810 billion ton of carbon dioxide is given out by Earth. Out of that, 95% is by decomposition and respiration of all the land biomass and aquatic biomass. That means plant, animal, everything on Earth as well as on Earth, including land and sea. Only 5%, but that 5% is a huge quantity, 40 billion, not million, billion tons of carbon dioxide is released by mankind. So what is the effect? So this shows how it happens. So the land emits like this, microbial respiration and plant respiration, decomposition, 440 billion ton, out of which land has got capability to absorb the whole thing plus another 11 billion ton. Ocean gives out due to surface, due to the ocean also has got large percentage of greenery in it called phytoplankton. It gives out 330 billion ton of carbon dioxide, but it can sequester means permanently absorb by means of photosynthesis, plus another 7 ton possibility is there. But unfortunately, today the man is producing 40 billion ton of carbon dioxide in various industrial processes, out of which only 18 billion can be absorbed by the Earth. So remaining for 22 billion gets added on to the atmosphere. The atmosphere, as you know, is about 5.2 in 10 raised to billion ton of air is there. So this 22 billion corresponds to 4.2 ppm increase in carbon dioxide in the year 2019. This quantity is slowly increasing. How do you know what I'm telling is correct or not? The reason was, for years, this shows carbon dioxide and this shows year from 900 to today. It was steady. How do we know? Because we have taken ice, carbon dioxide sample deep under Arctic region, which were trapped in the ice for thousands of years. They were taken out and their life was found out by carbon dating, and it was steady. But after the Industrial Revolution, the carbon dioxide level increased, and today it is at 400 parts per million. So post-industrial increase in atmospheric carbon dioxide is the primary cause of global warming. Here was a graph which shows how carbon dioxide increased and how water content, temperature also increased. So there were nowhere in the history, this slide shows 400,000 years, 400,000 means 4 lakh years of this type of measurement has been done. And no time in the history, the level of carbon dioxide has gone above 300 ppm. If you look at the time scale, it is rapidly increasing after 1950s. So what is the source for carbon dioxide? Man-made carbon dioxide is due to rapid industrialization and explosive growth of transportation. Both use, most of the pictures are missing because of some problem with the zoom. This shows how carbon dioxide come out of industry, come out of electricity generation. Both use fossil fuel. Their combined emission is 33 billion ton, because 1 ton of coal gives rise to, on combustion, gives rise to 3.5 billion ton of carbon dioxide, and 1 ton of petroleum product gives 3.1 ton of carbon dioxide. Concurrent to that, we had global deforestation. 30 million hectares of the forests are lost annually. That corresponds 5 times the area of Kerala. So that corresponds to 7 billion ton of carbon dioxide from reduction in photosynthesis as well as the forest fire. So how do we find a solution to this problem? Who is responsible for this emission is the first question asked. If you look at the country-wise share of the emission, first prize is by China, third prize is India, second is United States. But if you look at per capita emission, India was, here again the picture is lost, India was the lowest per capita emission. That is shown here. If you look at the world, it is 4.35 tons per year. China is 6.67 and USA is 15 tons. Whereas India is at only 1.57 tons per year. Because our per capita electricity consumption, because these are all interconnected, electricity, energy consumption is also on the very low side, only 5% of the global 26,000 terawatt hour electricity which is being created. That is why 20 years people were trying to find a solution to this huge financial, because of this problem, but there was no solution because of the huge financial implication. So we have the historic Paris Agreement, where it was decided to limit the increase in global temperature below 20 degrees centigrade, 2 degrees centigrade over the pre-industrial levels, or try to limit it only to maximum 1.5 degrees centigrade. But this is not dictated by somebody else. This is the beauty of this Paris Agreement. That's why everybody agreed for that. We ourselves will declare that this is how, that is called nationally determined contribution. This is how we will reduce our global warming. Then, but highest possible ambition. It will be presented in a global forum, and then the progress made will be reported regularly, and then in by 5 years, we are obliged to show a progression in the decrease. So developed nation will provide $100 billion annually to the country. So the whole idea is to get a carbon neutral world. Carbon neutral means whatever is produced will be sequestered by 2100, preferably 2500. But then, is it possible? This is a very interesting picture. If you see, today it is around 40 billion ton of carbon dioxide emitted. By 2100, if no action is taken, it will be close to 140 billion ton of carbon dioxide per annum. Temperature will be 4.5 degrees centigrade. If you go for that nationally determined contributions, which everybody has signed in the UN, it will still go to 3.5. That is how the UN is now making a fervent plea to all countries to go below the present level of carbon dioxide production. How is it possible? It is not possible unless we make some very great changes in our method of manufacturing, method of transportation, etc. Look, my dear friends, India agreed the climate agreement on 2nd October 2016. The estimated cost of the action plan is $2.5 trillion US. See, it's a huge amount. I cannot imagine what is 2.5 trillion US dollars. It is 1.1 times the gross national income of our country. So it's a huge challenge to find resources as well as find out appropriate technologies for the mitigation. So how do we prevent? One is increasing the plant biomass on land and in ocean. Second is to decrease the man-made carbon dioxide. Third is through climate engineering. That is solar radiation management as well as carbon dioxide capture and the storage. How do we solve this? By doing reforestation of what forests we have cleared, and afforestation means wherever it was no forests were there, like in the deserts of UAE, they have planted forests. So trees sequester permanently absorb on the average, because there are different types of trees, on the average 22 kilograms of carbon dioxide per year by photosynthesis. Trees reduce air temperature by blocking sunlight. Tree further cools when water evaporates from the leaf of the tree. You know that any vaporization is a process where temperature comes down. So one big tree equal to 10 room air conditioners. So you will say, oh, I have the solution. Plant more trees, best solution. No doubt this is the best solution. Then why worry? The worry comes here because it is inadequate for the present and projected emission of carbon dioxide. For example, let us work out. You can, if you have a calculator, you can work out. Today, we have 22 billion tons of carbon dioxide beyond the Earth's sequestration capacity. One tree can sequester 22 kilograms. So 22 billion divided by 22 kilogram is 1 trillion additional trees are needed. That means if you divide that by world population, 128 new trees are needed per person to neutralize this 22 billion ton of carbon dioxide. This 22 billion is every year increasing if we go like this. So where is the place for that? That means tree, even though it's a very good option, but unless we reduce in the other places, tree alone cannot solve our problem. Therefore, various methods are there. Why not we increase the sequestration capacity of the land and ocean? So what is called a biochar, which is produced by the pyrolysis of organic material to produce very porous carbon, which can absorb carbon dioxide and remain in soil. That is one method. Another one is to simulate the photosynthesis by phytoplankton. That means the plant in tiny green material on the sea, because you have a larger area of the sea, by ion fertilization of the sea. And also bottom of the sea has got very fertile manure, bring it up during some methodologies. But then who will do that? That is the question. So the sure shot technique is to reduce man-made carbon dioxide. So sector-wise, if you look at what is the carbon dioxide emission in each sector during the, this is the scenario in 2019, almost 46% is from electricity and heat, 23% is transport, and 19% is industry, others are minimal. So we have to concentrate more on these two areas, electricity and transport, then only we can come to a solution. Now let us look at electricity generation. If you look at the world electricity generation, world over, this, this 25 plus 10, 35, 65% of electricity all over the world is produced by thermal power plants, out of which 38% is from coal, other from gas and oil. Nuclear is 10% and renewable ones are 25%. If you look at it in India, 68% is thermal. But in Kerala, we can have the color up by telling that ours 72% is green electricity because it's a hydel electricity. But then Kerala produces only a very small, minuscule of against 26,800 trillion gigawatt electricity consumed. Kerala's production is only less than half a trillion in the whole year. So this is a very interesting picture. If you look at this carefully, this picture shows how many grams of carbon dioxide is produced when you make 1 kilowatt hour. That means 1 unit of electricity. If you use coal fire thermal station, 900, oil fire 700, LNG, that means methane fire 500, it's combined cycle this. But then these are the ones which do not produce any carbon dioxide: solar, wind, nuclear, thermal, and hydrothermal. But hydrothermal is very little available because it is available only where there is a increase in temperature. So, but then if you look at this, nuclear energy is a good source. Today, India has got only 2%. There's a plan to go to 7% in another 10 years. But nuclear energy, there is limited acceptability among people after the Chernobyl and Fukushima disasters. People now oppose everywhere, even though they want electricity everywhere. And hydrothermal, hydroelectricity, not hydrothermal, hydroelectricity. The problem is that it's limited source. Only when there is a good water you can have it. But then there is always an opposition, because if you construct a dam, it will submerge forests and also displace the tribals. So there is a need for more solar and wind power. And so India, in spite of having only 5.8% of the world electricity being generated in India has done a great thing in pledging to the United Nations that we will generate clean electricity, that is from hydronuclear, but mainly solar and wind sources by 2030, to which India is progressing very fast. Today, in India, we are having this green color is wind and yellow is solar. This is almost equal, but solar is going on increasing. And we have promised to the world that about 450 gigawatt of electricity will be produced through these two sources, renewable sources, essentially through solar and wind condition. We have set up very big solar power plant. This was a good picture of a solar power plant in Andhra Pradesh. It has shown, if I remember correctly, something like 24 square kilometers of area. And today we are able to supply electricity at 2.5 rupee per unit. This was possible because of the fantastic development in material science as well as in electronic engineering. This was the cost of the photovoltaic cell in 1977. From $76, it has gone down to $0.3. Then there was a picture of a huge solar power plant, because that various versions of the Zoom. I'm not responsible for it. Zoom has got some of the pictures will disappear in that. Favorable wind. See, wind energy, the problem is that the favorable wind only at limited locations. So we have to, there is a need to transport electricity from there to your user end. So unfortunately in India, transmission and distribution loss are almost 18% of the output against the world average of 8.5%. So look at this, including the Africa, the world average of the loss is only 8.5%. But in India, the loss of transmission is close to 18%, which is equivalent to, suppose it was not there, we could have saved 130 million tons of carbon dioxide emission to the atmosphere. That is why today the government is giving subsidies and promoting grid-connected rooftop solar electricity, because you don't have to transport majority of it to long distances. Now let us look, fortunately this picture has come, it's a good picture. Now let us look at the transportation sector. First, let us take the good transport sector. This is a very interesting slide. It shows the fuel efficiency. That means what is the distance that is traveled with 1 ton of cargo using 1 gallon of fuel using these 3 methods of transportation: truck, rail, and ship. 59, 202, and 514. That means in the ratio of 1:3.4 is to 8.8. So per unit mass, truck needs almost 3 times more than rail fuel and almost 9 times more than the sea transportation. But on the other hand, look at the fatality ratio. How many fellows will die per 100 kilometer or for a 1,000,000 kilometer run? This is a fatality. This is the train. This is the ship. This is the injuries. This is the one. But so ideally speaking, this is good for short hauls only, whereas train is good for the trunk routes, whereas for but the problem with ship and barges, they are very slow. Therefore, they are the ideal one for non-perishable. If you go to Germany today, you can find that the entire Rhine River, they carry their entire material through Rhine River. Unfortunately, in India, we don't have such a mid region. Sea is not there. Sea is there only through the peripheries. So we need definitely faster and more efficient good trains. But the problem is that they cost 10 times more than the rail. So need for using ships to connect coastal belt and for rejuvenation of waterways. Now let us look at the passenger transport. This is a very interesting picture. This shows how many grams of carbon equivalent emission takes place per passenger kilometer by different modes of transportation. I don't have the time to go through it. On the topmost, the worst fellow is the large car with 15 miles per gallon. MPG is miles per gallon. And the best fellow is school bus and Eurostar rail. This is expected because one passenger capacity, one train can take 10 times the bus load and one bus can take 10 times the car load. So we need more convenient public transport. And also I have written, oh, here again, picture is lost. Here shows overcrowded bus and overcrowded rail. I have also written cultural adaptation of using public transport. If our, the passengers should not become, go with the chamis and things like that, then, people will be reluctant to go through the public transport. Kerala is a place where there is a maximum road accidents. 12 deaths per day and 117 road accidents. So there is a need for fast track railway, but whether it should be central or side, that is all political decision. I don't have any comment on that. If we have city bypass and road without potholes, there will be a 10% increase in fuel efficiency and the decreased carbon dioxide emitted will be equal to 1 million ton of carbon dioxide per year. So yet another interesting thing, which especially for students, you may look at this. See, now everybody is going for electric car. But I have shown you 2 types of electric car. If the electric car uses grid electricity. That means the electricity which is generated from a coal-fired electricity that is from the grid, it is used, its emission is only marginally better than that of a small car. Actually, improvement in electric car will come only if the charging of the car, because electric car has to be charged one in every 100 kilometers. Charging is done using solar power. And if every car today rolls out in India becomes an electric car, we don't have that much of solar energy right now available. That's why India has pledged to create more solar energy. Another thing is, so let us look at this. So here there was a picture that is again missing. Now, then why not go for a green fuel? That is, day for us today is Indian Times of India also, there was a good article on this. Green fuel means fuel which produces zero carbon dioxide. If you take coal, petrol, methane, CNG, compressed natural gas, and hydrogen, this shows carbon dioxide evolved zero from here. This, what is given in bracket, shows its fuel value. That means its calorific value. So this is the best fuel with zero energy. Then why not use hydrogen? The main problem of using hydrogen is its method of making. Today, industrial process of making it is from naphtha, what is called the reacting naphtha with water vapor at high temperature. But 1 ton of hydrogen so produced will produce 6.7 ton of carbon dioxide. So that is not a viable mean. If you use electricity from grid, again like in the motor car, the net carbon dioxide output will be more than without a hydrogen cell. So hydrogen can be considered as a fuel only if you can make it by electrolysis of water, using solar electricity, or by photoelectrochemical splitting of water, and use the energy through fuel cell. Because those of you in higher classes, you know that the conversion from chemical energy to electrical energy is more efficient than chemical energy to mechanical energy. So ICM engines are less efficient with hydrogen in comparison to you are having a hydrogen fuel cell. From that, you run your turbine or run your transportation cost. So this is actually the route: solar power, split water, and then store hydrogen, which is used for this fuel cell, hydrogen fuel cell. Here I have shown a bus running on hydrogen fuel cell. Here there was an animation of the fuel cell. Then climate engineering, at another, I should say it's a quixotic idea right now, is to deploy very large space mirrors in stable orbits around the Earth. Reflect the sun ray away from the Earth when it is hot, and then bring it down when it is cold. It's a funny idea because it costs so much of money. Now, you know, it's about $25,000 to take 1 kilogram to the orbit. So this many things are to be taken to the orbit. The money will, everybody will become poor. But this is an idea which may become facile later on. Or use aerosols to cool down the air, or seed during solar rain. Use the cloud when it becomes too hot. You cloud seed so that the cloud will protect Earth from hot sun, or capture the carbon dioxide when it is being generated, and then store it underground either as sodium or calcium carbonate, or convert it into a supercritical liquid and then take it down very deep underneath the underneath the Earth, and then cap it there with various mechanisms. So, my dear friends, I am concluding because 8 o'clock was the time given to me. I will conclude with 2 slides. Global warming is a reality. It is a threat to humankind. its prevention is a huge challenge, especially to developing countries. Little help we can expect from developed countries who are mainly responsible for global warming. Because already the previous American president has said openly, sitting in his comforts, he has said, I represent the people of Pittsburgh, not Paris. That means he was denouncing the Paris Agreement. Without of no concern to the future generation, like a first-class passenger in the Titanic. But he also will sink. Why? Because carbon dioxide generated anywhere in the world, because it's a gas. Even if you generate in Kerala, it will go back to New York after a couple of weeks or a couple of months. So global warming is a phenomenon which can be combated only by collective effort of all concerned. Global warming cannot be combated by one country. India, insofar as India is concerned, we have to strike a balance between alleviation of poverty and mitigation of the global warming. So, my dear students, you are the next generation. You have to think out of box to find out innovative solutions to the global warming at affordable cost for the country. Otherwise, what will happen is our global warming will be like this. Here again, a picture. It was a very good picture. It was missing. It was showing here a picture. You imagine a picture you would have seen in Patram Junction. A Bihar, a person from poor man from a Bihar, trying to protect himself with that what do you call that that Ella type of a thing to protect him from the hot sun. Okay, so leaders, policymakers, scientists, technologists, economists, students, social organizations, everybody have to work together to go combat global warming. We need a new model for our development. Today, if you get here again, there was a picture of a motor car. If you get a Provident Fund advance, you will immediately buy a motor car. Whereas if you see a man cutting a tree, you will stone at him. But then look at this picture. Running a motor car, even a small one, for 9,000 kilometers a year, which is the distance a person residing in Neyatingara to come to Secretariat every day and go back, he or she will release 2,230 kilogram of carbon dioxide with a mileage of 10 kilometers per liter, which is equivalent to cutting of a tree. Because carbon dioxide sequestered by a grown-up tree in 100 years is only 220 kilometers, 2,200 kilograms. So the daily consumption of petrol and diesel in Kerala is 12 million liters in 2016. It has gone at least 30% higher. The number of trees required to sequester carbon dioxide from it is 464 million. That is equal to 14 trees per person. So I'm not trying to frighten you, but what I'm trying to tell you is that we need a new model for our future development. See, these are not, we should not consider this 10 crore worth of car or a 7,000 crore worth of house as the real model for our future development. I'm not denouncing that you don't have, but that should not be our aim for our development. But our development should be a target to sustainable development that will make Earth livable for us as well as our future generations to come. So I will give you a new slogan: sustainable development with greenhouse gases within ESL. ESL means Earth Sequestration Limit. May God bless you to attain this. So thank you very much for your kind attention, for listening to me. Okay, that is the end of my talk. Now I leave it to the organizers, as well as I am going for answering any questions you would like to ask me. Okay.
Thank you, sir. Thank you so much. So let us give him a good clap. He has made a wonderful presentation, very systematic. And in a very simple terms, he has told us what is global warming, what is its effects, how to mitigate that. Very informative lecture. And also he has given us to you, especially you to children, students, the challenges ahead, because you are the people who has to live in this earth much more than many of us. So there are so many challenges in front of you. Along with the challenges, there are lots of opportunities for you to innovate and make a solution. Also, it has a lot of dangers if you relax. That's the message he was giving. So thank you, sir, a lot. Now, as sir has told, there is a possibility you can ask certain questions. And I suggest you put the question in the chat box so that the cross-talking will not affect us. Otherwise, if you put on your mic and everybody start talking, nothing will be heard. So better we put the question in the chat box so that it can be answered. So the floor is open to you now. We are expecting the questions in the chat box.
James, you can read out the questions to me.
Yeah, I will read out the question. I think has come so far. Yeah, some people have written excellent talk. It's a very informative one. Request to please share this presentation. So many things. Okay, but anyone has a doubt or a suggestion or an idea to solve the problem? Anything is welcome. Sir, let me ask you one thing, sir. Whether any country has made any law so that this carbon dioxide emission can be minimized? Any law generation has happened in any country?
Yeah, I see. I have not touched upon certain aspects like what we call carbon trade.
Yeah.
That means one idea was that if you can save carbon dioxide in emission, if you go green, then you can sell that much carbon credit to a country who is in red, and then try to solve a problem. But this was a quixotic idea because it was essentially came from the capitalist concept that anything on earth or heaven can be purchased through money. It has not worked. That was the consequence of another. Otherwise, the many countries, some of the countries have made it, even our own country has made it forbidden you from cutting trees, get approval from cutting. Unfortunately, people are, that is what I was trying to show you by scientific calculations. Everybody thinks that, okay, if I plant one tree and if I don't cut a tree, the whole world will be saved. Yeah. It is the best step available. However, by resorting that alone, we will be able to solve only about 15% of the problem what is happening right now in the world. So we have to find out the ways of reducing carbon dioxide. The ways of reducing carbon dioxide and other greenhouse gases is to curtail its use. But then, unfortunately, today, the degree of development is and conveniences are highly dependent on electricity, highly dependent on transportation, highly dependent on manufacturing. All these three need fossil fuels. They burn and then make carbon dioxide and other gas, nitrous oxide, etc. So what is the way out? The way out is only to find out alternate means of doing that. Today, but then they have also got problem. As I told earlier, today, for example, if the entire electricity is produced through lithium-ion cells, 26,000 terawatt hour of electricity, if you want to have equivalent number of lithium-ion cell, even you excavate the entire earth, you will not get that much lithium. Yeah. So that is why this is a fantastic issue. The world has never come across such an issue. For example, if a nuclear war is there, only some countries who press the button are to be addressed. If if virus is coming, there will be some treatment or some disease. But in this type of a thing, the entire country, entire methodology, entire nation have to put in their efforts, then only thing will come through. That is why it took 21 years for all countries put together, chit-chatting among themselves to come out through. Fortunately, India government is very proactive. India was one among the first few countries to sign the Paris Accord, in spite of the fact that, as I said, it costs $2.5 trillion to do that. And we are on the move. For example, our solar electricity rise is so high. Unfortunately, in Kerala, you don't have that much land available, but wherever land is available, they are trying to make. Okay.
Sir, when you say the solar energy, if you tap, you reduce the CO2 emission to a great level. Are you considering the CO2 emission in the process of making the solar cells itself?
No. It is. See, you are finding out an alternate source of energy. Suppose the same energy you are making with coal.
That's right.
That is the thing. That is the effect of. Yeah, that is what I was trying to give an example. Suppose you have an electric car and you charge it with electricity generated from the coal-fired generator. You are effectively not reducing any carbon dioxide.
Exactly. Yeah.
Even though there is no emission from your car, but there is an emission
elsewhere,
somewhere else. But if you have the same car charged with solar energy, then neither at your car nor at the production center there is any emission. That is what it is.
Okay, sir. Nambudiri has put a question here. How about cheaper technology for solar electricity production and electrolysis method for producing hydrogen?
Oh yeah. That is, Nambudiri, that's excellent. I saw you one. It's very nice that you asked a question. It's a very, very pertinent question. See, in fact, I have shown you a graph. I didn't have time to. Today, solar energy has become within our budget because there was 100-fold reduction in making solar cells. As I have shown in my slide, in 1977, 1 kilowatt, 1 unit equivalent of solar cell was costing, if I remember correctly, $77 per kilowatt hour. But today it is 0.3 kilowatt hour per hour. So it has come to almost a very minimal level. Now, further possibility is there if you can increase the efficiency of conversion or photo efficiency. That means right now, as you know, the current PV cells, they convert about 17% of the quantum efficiency is only 17%. If you can increase to say 34% or 50%, then the cost reduction, equivalent cost reduction will be 2 times, halved, provided the material cost is also the same. Second thing, Namburi was asking about hydrogen energy. Hydrogen, if you use electricity, split it, then input energy is same as the output energy. But because of the Carnot cycle laws, you will generating effectively more carbon dioxide. That is why the methodology is that you use solar power to split the energy, either using solar cell or a new branch of chemistry known as photovoltaic catalysis. That means certain catalysts are there, which are like some ruthenium bipredyl and things like that, which can increase the splitting at the only thing the rate can be increased. Also, you know, the thermodynamics cannot see energy has to be supplied. So that's why sun energy will be, instead of cell, this catalyst will take the sun energy. See, whatever you say, the energy can neither be created nor be destroyed. The bond energy has to be broken between hydrogen and oxygen. Therefore, it has to come. So use sun for that purpose. Okay.
There's somebody, Satish Jonas put a question. Can you explain some reason why the present day climate change, like rainfall, extreme flooding, etc., are occurring at a faster rate than older times? Why it is happening faster rate now?
Yeah, I have explained in one of my slides, but I will tell you, I don't have, see, if I go back to the slides, it will take time. So I will explain to you. For every 1 degree rise in temperature, there is a 6.7% increase in the vapor, water vapor going into the atmosphere. Okay. So when temperature increases, the amount of water vapor in the atmosphere will be more. So when it condenses, condensation occurs in large quantity of water will condense, and therefore the fury of the rain will be more. And when there is a more rain falling on top of the hill, especially the sloping hill, where the reinforcement of the tree root, etc., are cut or it is disturbed, there will be landslide also. So this is expected to happen. Only difference is that this water vapor coming to the earth, to the atmosphere, is on a global scale. But where it moves, it's very complex to predict. This year it may move to Kerala, next year it may move to somewhere else because of the velocity of the wind and the temperature gradient, which is a very complex function about which I don't have any expertise to tell you. But what all I can tell you is that the total amount of water vapor going into the atmosphere increases considerably with increase in the temperature of the sea, and therefore when it condenses as either as rain or as snow, it will be more. That is the reason. Okay, I hope I have answered you. A few more questions are there. I see.
Okay, one more question is there, sir. Chanvi Shine. The India is the most polluted country. How we can reduce the pollution?
Pollution is a very multifarious activity. Pollution comes from soot, dust, poisonous gases, solid pollution, and then also the liquid pollution. Solid, liquid, and gas. Carbon dioxide is not a pollutant that way. It is a global, it is a very essential step for human being. Suppose, I mean, on the other hand, I will give an example. Suppose the global level of carbon dioxide goes to 250 parts per million. The entire globe will chill, and then there will be equal amount of death due to cold climate. So that is why the nature was beautifully balancing about 300, 280, 300 ppm. When it goes up, see, earlier, I didn't have time to explain to you, during the last 400,000 years, there were 7 dips were there in the temperature axis. So 7 times they were called glacial eras, there where the temperature went down something like 5 to 6 degrees from the normal because of the very low carbon dioxide emission. And also certain regions in the certain region in the orbiting of the Earth. So I say I don't have time to explain all those things. So other pollution like solid gas, soot, and then sulfur dioxide or CFC, all these things, there are laws to, for example, when you know our farmers burn or we ourselves burn our waste, we just take to the road, take it from our house to the road and then keep it and burn it. There are a lot of soot generated. Soot is unburned carbon that will be hanging in the air. So that is one type of generation. If you burn plastic, it will generate what is called dioxin, which is a toxic gas. So there are various regulations. See, unless you and I cooperate in these aspects, nothing can be done. By rule, a policeman cannot run around every day from house to house to see where you are dumping these things. But that is what the civic sense has. That is what I was trying to end up by telling that we need a new civilization. We need a new model of development, which not only the greenhouse emission, but the entire pollution has to be within acceptable level. Okay. good question.
Sir, I think some people may be reluctant to type out the question. So I am allowing the mic to be on.
Oh,
If somebody want to ask, okay, one by one. If anybody is particular to ask a question, please.
I have one. I have one comment.
Hello.
I have one comment.
Please.
Unnikrishnan Nair. See, just about the solar cells, there was a question. See, the efficiency of the silicon solar cell which we are using now is slightly larger than 15%.
Yeah.
And making of a silicon solar cell is a costly. It's a costly affair. I think now we are also making, but mainly it is coming from China.
Yeah.
China, and that is one thing. And research is going on for making organic solar cells. And now I think they have come to 10% in the laboratory, 10 to 12% in the laboratory. In future, we can expect the efficiency may be better. Then the cost will come down. That we can expect only by research, and we can hope that it will come down one day. Then with regard to the lithium, which is used for storing the batteries, lithium is available only in very small level. It is available in Latin America and also Australia. But a good number of this lithium is contracted by China. Freely we cannot purchase lithium. That is not available. But some one or two institutes in India have developed a process to get this lithium which has been used in the batteries.
Recycling. Okay.
Recycling. And I think that has been done by one institute I know, and Tata Chemicals or some such company has taken the patent and they are developing it. So recycling is one thing that you have to attempt in such cases. Lithium, and also in gold also it is.
Cobalt also.
Cobalt also another material, which is not available in the world.
Yeah.
So that is necessary for making the electric vehicles, especially for the magnet.
Yeah. Thank you, Professor Unnikrishnan Nair, for supplementing my points.
As
he said, see, even though China we say as our enemy, but China is the real reason for bringing down the solar cell cost to something like 0.3. I have shown in one of my slides, $0.3 US per kilowatt hour. Chinese contribution is tremendous because there is a lot of workforce available. I mean, I'm not going into the political reasons, but that is the reason. As he very correctly said, there is organic photovoltaic cell in ISRO. In our group also, we were trying to do some work, but then there is a problem of stability and so on. All these things will come to. See, what is projected in one report, it is stated that somebody has made photovoltaic cells with 40% efficiency, but it's one of the closest guarded secret. They have not even patented also. If you patent that, there is a likelihood of somebody copying. Yes, I find Mr. Stanley wanted to ask some question.
Yeah. And I just wanted to, I'm a green builder. I just wanted to add a couple of points. One is that using timber for construction is actually reversing global warming. You have to grow timber and use it. These forests are carbon neutral. They absorb carbon and release carbon. So that is one aspect. Also, what sort of trees you are growing? Like trees like tamarind has a high density and the ability to store more carbon. Hard timber is very, very important. And to use it, if you use it for this kind of timber can stay on earth for use like furniture, building 300 years, 400 years. So that is very valuable to reverse global warming. Other thing is soil carbon is something we have ignored. In a good forest soil, the organic carbon content is about 5%. And in a bad agriculture practice lead to a reduction of the soil carbon. That's a huge reserve of carbon which we can pull down in soil. So the agriculture practice, if you increase mulching and organic carbon, it can reverse global warming to a great extent. That is another aspect.
It's a good point. Actually, what he said is very correct. That is why even biochar, people are trying to find out synthetic, carbon, which can sequester more carbon than what is the natural one. Biochar. In fact, one of my PhD students actually worked on that type of similar material also. See, this is true. What I quoted 22 kilogram per tree is on the average from very thin to the teak tree. So that's an average. When you make a global average, you have to take an average that. Definitely, it's necessary to plant trees which can sequester more carbon dioxide. But then whatever you do, our present emission is so high that whatever tree you do, you may be able to augment. Currently, it is only 15% of the sequestering is feasible. Maybe even if you put double the thing, it can go only to 30%. But still, we have to reduce our emission. And this is going on increasing. See, that's what I was, I didn't have the time to explain to you. If you imagine that the half of the world will turn to the standard of living of the United States by 2050, then the global average temperature and also no modification in our industrial process or electricity generation or transportation, then the global average temperature will go up to 6 degrees centigrade, where there will not be any Sri Lanka, there will not be half the Australia will be out. All these things are a big problem, very great problem. I mean, people, because see, we are worried about COVID-19 because if we get infected, we may die tomorrow. But this is a slow death, slow death of the earth.
Yeah. So, what I was saying is that greenest building is the one fully built on timber because you are storing carbon. And the old understanding has to change. I mean, cutting trees, you have to cut trees, but also plant trees. It has to accelerate.
Yeah, but then there is a limit to that. Obviously, if you can, you see, paper is another great user of the wood. Paper and our furniture, construction, all these things need wood, and you cut, you replenish that. Even if you replenish, it takes years to come back to the growth of that level. And therefore, there is always, see, there was in one of my another lecture, I was showing a interesting picture of Shah Rukh Khan trying to get in a lady into the train in one of the movie, Train was moving fast. Shah Rukh Khan could get the lady in, but not a global warming. It is moving very fast, and if you plant a tree, it takes years to go to the same status. Okay. Next question.
What is one question? Janvi Shine, is flex fuel better for the environment?
What is that? I didn't hear.
Flex fuel. I don't know what.
What fuel?
Flex. F-L-E-X.
I don't know. I don't know the answer.
I don't know.
Okay. What is flex fuel? If you can explain, then probably.
I do not know. I do not know.
No. The person who asked can explain what is meant by flex fuel.
Janvi Shine, can you just elaborate what you mean by flex fuel? I think the person is not there. Okay. Sir, the time is nearing 8:30.
Yeah.
Anyway, this was a very wonderful evening. So I want to thank Dr. K. Ninan for this evening. And also I wish to thank Professor Unnikrishnan, Stanley, Sri Nambudiri and all that who made their questions very live discussion. And thank you very much. And we also thank YMCA President, the chairman of this program, all the board members, all those who attended, all those who contributed,